Welcome back to Math Concepts. In this video we are going to discuss how to determine whether two related statements are in fact equivalent. In our last video we talked about three statements that were all related to the conditional statement. Okay, so we have this group of four statements now. We have the conditional, we have the converse, we have the inverse, and we have the contrapositive. Last time we looked at truth tables and we saw that the original conditional statement and the contrapositive were logically equivalent. And the converse and the inverse were logically equivalent to each other. Okay, so you have these two separate groups. The conditional statement and the contrapositive, the converse and the inverse. So they're equivalent to each other, but they're not equivalent to stuff in the other group. So we'll look at some examples of that, and we'll also look at instances where using the contrapositive can help you determine whether a statement is true. All right, so the key ideas that I want you to take away from this video are how to determine whether two statements are equivalent, and secondly, to use the contrapositive to figure out whether a statement is true. And this is something we discussed last time. We have these four statements. We have the conditional, the converse, the inverse, and the contrapositive. The conditional, standard if P then Q form. Converse, you switch them. Inverse, you keep them in the same spots, but you do the negation. And for contrapositive, you negate and you switch. So let's look at these two statements right here. And we'll determine whether they are equivalent. Okay, so the first statement is, if a number ends in 5, then it is divisible by 5. Second statement, if a number is divisible by 5, then it ends in 5. Okay, so statement A, we'll treat that as the original conditional statement, if P then Q. Statement B, let's look at the structure of the two of them. Right, so statement A was, if a number ends in 5, then it's divisible by 5. So statement P is number ends in 5. Statement Q is divisible by 5. So we can see that in statement B, they've been switched. So if we're treating statement A as our conditional, statement B is the converse. So these are not equivalent. If we go back up here and see what's going on, the conditional is equivalent to the contrapositive. The converse is equivalent to the inverse, but not the original conditional. Okay? So by kind of analyzing the structure of these two statements, we can tell they are not logically equivalent. Okay. Let's look at another set of statements. So statement, this first one here. If I live in Nashville, then I live in Tennessee. So we'll treat that as P implies Q. Okay, so statement P is live in Nashville, statement Q is live in Tennessee. All right, so this is not Q, not P here in the second statement. If I do not live in Tennessee, then I do not live in Nashville. Okay, so we've got our original conditional, and the second statement is the contrapositive. So those are equivalent statements. Right, so we've got those two pairs. Conditional and contrapositive are equivalent, as are the inverse and the converse. All right, let's look at this right here. Write the contrapositive to determine whether the original statement is true. Okay, so the original statement is this. If 3 plus x is an odd integer, then x is even. Okay, so let's look at the contrapositive. if x is odd, all right, so I guess technically I could have said not even, right, but those are kind of the only two choices, right? You're either even or you're odd. So if x is odd, I take the negation of the last part and then the negation of the first part. Then 3 plus x is even. Okay, now this right here, this is a true statement. And that's because an odd plus an odd gives you an even. Okay, so because this statement is true, then the original statement is also true. Okay, so if you have sometimes a statement that looks a little complicated, maybe taking the contrapositive can make it a little more digestible. And here, notice also, we started with the output of a process. Okay, we're talking about what happens if 3 plus x meets a certain condition, and then we're going backwards to the input. And the contrapositive kind of reverses it to the more natural order, where we're starting with the input and then looking at the output of this. Okay, so sometimes that contrapositive can be quite helpful in determining when a statement is true or false. Okay, one more example. Okay, if today is not Wednesday, then tomorrow is not Thursday. So a couple of things with nots in them. Okay, so let's do the contrapositive. If tomorrow is Thursday, then today is Wednesday. If tomorrow is Thursday, then today is Wednesday. Okay, of course, remember when we negate something that has not in it, we just take out the not. And this is, of course, a true statement. If tomorrow is Thursday, then today must be Wednesday. So that statement is true, so the original statement is also true. Okay.